This video shows how to set up a custom pipeline in ZEISS arivis Pro for high-content image analysis for genotoxicity studies. For a full case study, please refer to the ZEISS Insights Hub page, and the link is given down below at the bottom of the screen. And in the next few minutes, you'll learn how easy it is to set up image analysis pipeline for this specific study by using a single field from a single well in a multi-well plate. And once this pipeline is set up, it can be executed to analyze multiple samples via batch processing in arivis Pro or parallel processing for scaled analysis in arivis Hub. Now, before jumping into image analysis setup, let's first quickly discuss the approach. For genotoxicity studies, the S and the M phases in the cell cycle are important because in both phases, cells need to coordinate the correct segregation of genetic material. So this makes these two phases especially vulnerable to genotoxic treatment. Microscopy, of course, is quite often used for these type of studies, genotoxicity studies, because the primary outcome of genotoxicity, like DNA double-strand breaks or micronuclei, they can be easily detected via microscopy imaging. Also, various antibodies now are available to detect features of interest. For example, with 53BP1, the DNA damage regions are highlighted as green spots, or we call them foci, within the nuclei. And EDU or EDU stain can be used to detect cells in the S phase. And of course, DAPI always allows us to detect all nuclei. So the pipeline covered in this video involves first segmenting all nuclei using deep learning, of course, and detecting DNA damage foci using blob detection algorithm available in arivis Pro. Then nuclei in the S phase are identified by setting a threshold for the EDU intensity for, of course, the nuclei that just got segmented. And finally, all nuclei with DNA damage are identified by compartmentalizing the foci within the nuclei. And similarly, EDU high nuclei with DNA damage are identified by compartmentalizing foci within these objects. So with that background, let's see how easy it is to build our custom pipeline in arivis Pro. So click File, Open, and let's open our genotoxicity dataset, which is a 3-channel dataset that has EDU, DAPI, and DNA damage channel, which is in green. Let's adjust this visibility a little bit to see our foci. We may have to zoom in. There you go. So we have these foci, and let's turn the DAPI and EDU back. And to start the analysis, let's click on the analysis panel. That opens up this panel on the left side, and let's click New Pipeline. That opens up our pipeline. Now, for ROI setup, instead of working on the current image set, which is this entire image that I have open, let's go ahead and pick Current View 2D. This allows us to define our pipeline by looking at the feedback applied on this current view. So whatever you see on the screen, this is our reference, and we are adjusting the parameters. We are adding new operators, image analysis operators, by looking at the feedback on this specific field. This is often faster than actually applying it to the entire data set, especially if you have a very large data set. Okay, so let's continue by adding the next operation, which is the cell segmentation. So let's go ahead and collapse these and only open the segmentation part. And here, let's go ahead and find our cell pose-based segmenter under Smart. And for channel, let's go ahead and use DAPI to segment our nuclei. And for average size of nuclei, we can measure a random nucleus and accept that value. And let's go ahead and change the name of the output to all nuclei, so later on we know what it corresponds to. And also for output, let's change it to random color, so all the nuclei are displayed in random colors after the segmentation. So let's run the pipeline until this point by stepping it through. And this should be near immediate because we are only segmenting the current field. So it should be real-time feedback. And the segmentation looks good. And to turn the objects on and off, check this button at the bottom, and the segmentation looks good. We are ready for the next step of adding the blob finder to actually detect the foci. So the input here is going to be the DNA damage, the green channel, and the diameter, again, you can measure it, you can zoom in, you can measure. They look like it's about 1 micron. You can actually, let's see if we can measure about 1.5. I don't want to zoom in. I want to keep this field at this point. So let's go ahead and apply type 0.72. These are small enough. And for probability, let's type a value of 10. Of course, you can also use this tool and hover it over a few of the foci to actually get a good estimate of that value. I'm changing the output to rename it to DNA damage foci. And let's change the color to pink and run the next step, which would execute our blob finder. It should again be pretty fast. And all the blobs or the foci are now detected and colored in pink. Okay, the next step is to, of all the nuclei, identify the EDU positive ones. And for that, we don't need deep learning. We have already segmented our nuclei. So we just need to apply a threshold, for example, say 5,000 or 6,000 in terms of intensity, and then say anything above that intensity, I'm going to label that or classify that as EDU. So that is the next step. So let's go ahead and add an operation or to pick an operator where we are going to use the objects because we have already segmented nuclei. So let's use objects. And under objects, let's select the first one, object feature filter. We want to filter these objects based on intensity. So first, let's select the right input, which is all nuclei. And for the parameter, instead of volume, let's change this to intensity coming from our channel 1, which is the EDU channel. And I'm going to select mean intensity and say OK. And let's type a value here. And now the question is, what value shall I type? Let's actually open this objects table. And here, let's close the charts. Here you can actually see the mean intensities. But once I open the chart, I can visualize it a bit better. And let's say right around 8,000. I can comfortably say above 8,000 intensity, it is EDU positive. And go ahead and type 8,000. It's up to you, of course. And let's change the value to EDU plus nuclei because these are the nuclei that are EDU positive. And let's also change the color to something different, yellow, and run this next step. These are all the EDU positive nuclei in our field of view. I think we're ready for the next operation, which is to compartmentalize the foci and nuclei, meaning what nuclei, of all nuclei, identify the ones that have these DNA damage, and we are using the foci for that. And we'll also add another operation, compartment, where we say of all the EDU positive nuclei, which ones are the one, which ones actually have this foci. So first, let's start with all nuclei, and I'm going to use relationships and compartments. And the first input would be all nuclei. So of all nuclei, and the sub operation here is go ahead and find basically the foci. So of all nuclei, which ones have the foci? And while we're here, let's also add the second compartment, which is instead of all nuclei, it's going to be EDU plus nuclei, it's already there, and DNA damage foci, that's it. Let's run these two steps. And yeah, there you go. And now you can see how we have been working on this specific field, and we are happy with the pipeline, and we are ready to actually run this pipeline on the entire data set or a batch of data. So let's go ahead and, in this case, change our ROI to this from current view to current image set, and just hit this icon to run the entire pipeline, segmentation of nuclei and foci, and compartmentalizing them into the last two steps. So here is the final result visually, but of course you can open the objects results table to get all kinds of parameters about this specific analysis, export them, and perform additional analysis. This is how easy it is to create your own customized pipeline, no matter how complex you think the operations may be. It's very easy in Arivis Pro to actually connect all these operations and create a very highly customized pipeline. Thank you.